Hey everybody, Mr. Judson here. So one of the things that we do a lot of in calculus is we talk about slopes and tangent lines. And so this idea of writing the equation of a line, you may remember that I said this last year, it never goes away, never. We did it in pre-algebra, we did it in algebra, geometry, algebra 3, 4, we did it last year in pre-calc, and now in calculus we still have to write the equation of lines. So somebody out there must think that's an important idea. So today is really about reviewing what we know about linear equations. Okay. So if we write down the things that we know, probably the first thing that comes to mind when we say a linear equation is y equals mx plus b. Usually that's the first thing people think of. And this is called slope-intercept form. Now, we also, last year, we used this form of an equation quite a bit. Y minus y1 equals m times x minus x sub 1. And you might recall I said, that's the one I'm always going to use. And my only reason for that is it seems like fewer people make mistakes using this form of an equation than this. Again, I don't know why. I've just seen it happen as a teacher. So this is called point slope form. Okay? Slope intercept because we know the slope and we know the y-intercept. Point slope because we're plugging in the values from one point and we know the slope. And there's one other form of an equation that's pretty common, and it looks like this: ax plus by plus c equals 0. And a, b, and c can be positive or negative, so we could have some negative signs in there as well. This is called general form. And every now and then, I don't know, books will ask questions and they'll say, give your answer in general form. And a couple things that we need to make sure we understand about this is, one, the whole thing needs to be set equal to 0. Okay, that's the first thing that has to happen. Second thing is you always start with something positive. So if I put some side steps down here, a is greater than 0. Okay, I don't want a negative number here. I suppose I could say greater than or equal to, because if this was gone, I would have the line y equals something, and that's just a horizontal line. So I suppose we could say that. If a is a negative number, I'm just going to multiply everything on both sides by a -1 to change that. Or move everything over here so it becomes the opposite, and then rotate your equation around. Okay, but we want to make sure that's a positive number. And the second thing is no fractions for decimals. So if I had something like 1/2, to get rid of the fraction, I just multiply everything on both sides by 2. When I say multiply on both sides, we have to do that, but 0 times anything is still 0, so that's really not going to change. If I have a decimal number like 0.5, then I'm going to multiply everything on both sides by 10. That slides the decimal point over one spot, and we get rid of the decimal. Now somebody could say, well, why don't you just multiply by 2? Well, I could do that. That'd also get rid of it. But the idea is however many digits you have past the decimal, you multiply by 10, 100, 1,000, whatever it takes to move those decimal points over. Okay. So we'll see it occasionally. They ask us for something in general form. But, this is what I usually start with. This is what I'm trying to get to. And I told you guys last year, if you don't like this, if you want to just use y equals mx plus b, as long as you're getting it right, keep on doing that. There's nothing wrong with it. Okay, good method. So let's see, what else do we know about lines? Let me get a little more room to write here. We know they have slopes, and so So usually when we say slope, we think y2 minus y1 over x2 minus x1. I remember one year, somebody had actually said this backwards. They said y1 minus y2 over x1 minus x2. And a few people went into a tizzy fit, you know, because they said, no, that's not right. You got to write it this way. And I was like, well, I'm not really sure if that's wrong. Because if I write down 2 points, who's to say this has to be the first point and this is the second one? And what if I do this? Right? So it really doesn't matter which point is called point 1 and which is called point 2. What matters is that we're consistent here. If this y value came from the second point, then this x value has to come from the second point. Or if they both came from the first point, that would be fine. Okay. Words that we use quite a bit: rate of change. We're going to use those a lot this year. Remember, I told you one of the number one things we talk about in calculus first semester is derivatives. It's about all we do. And derivative means slope or rate of change. So we're going to hear those words more than you could ever imagine, almost on a daily basis. All right, so let's see. We got slope. What else do we know? Parallel and perpendicular lines. So we know that parallel lines have equal slopes. Okay, it makes sense to be parallel. You know, they got to be the same distance apart, so they got to have the same slope or steepness. And so we'll just note those are always equal. Perpendicular lines have negative reciprocals for slopes. And let's just make sure that we know what that means, because a lot of times people think perpendicular slopes have opposite slopes. And opposite just means plus or minus. The opposite of 5 is negative 5. Those are not perpendicular slopes, okay? It would be like this. If I said that I've got one slope, we'll call it M1, equals a negative 2/3, then the perpendicular slope to that, I got to flip it over, that's the reciprocal part, and then change it to the opposite. So that would equal 3/2. Okay? All right, so that's the stuff we need to know. Now we just need to do some sample problems. All right, so I stole this example out of our book. It's a little blurry. I can't really get it to focus in, but hopefully you can read that. It says here the population of Oregon was about 3,831,000 in the year 2010, and about 3,970,000 in 2014. Find the average rate of change of the population over this 4-year period. What will the population of Oregon be in 2024? Okay, you guys go ahead and try that real quick. So don't forget, you want to hit pause. I'm only going to wait a few seconds and then start working on this. But I want you guys to have a chance to do it on your own before I start showing you the answer. So what we said last year was average rate of change. Average rate of change is just the slope. Okay? And we'll see these words a lot this year as well. It's just the slope. Okay? So I want to do y2 minus y1 over x2 minus x1. So first I need some data points. And remember, time always gets the x value, or x always gets the time value. Okay? So I'm going to write this down as 10, 3831000. And my second point is, if that's 10, we'll call this 14. And then 3970000. There's my 2 data points. So if I want to find the average rate of change, which is just the slope, I'm going to do y2 minus y1. 3970123 minus 3831123, all over 14 minus 10, which is 4. And so if I subtract those, I'm not ready to do subtraction in the millions yet. All right, so subtract my y values, I get 139,000 divided by 4. And I got 34,750. And remember, one of the things that we're always thinking to ourselves is, what does that slope mean? I don't want to just find a number and move on. I want to think about what it means. So our y values here represent the population, so that's people. Our x value represents time, so people per year. And this is the amount of people that are moving to Oregon each year. It's how their population is changing. So people per year. So, so the last part of this question, what will the population of Oregon be in 2024? So what we can do is we can say that the population P, it doesn't matter if you started with this number or this number. I'll just take this. Was 3,970,000 plus we're adding 34,750 for a certain number of years. So from 2014 to 2024, that would be 10 years. And so I just need to throw that in the calculator now and see what I get. 3970123 plus 34750 times 10. And I've got 4,317,500 people. Always include your label. There it is. Let's try another one. Just to kind of back up and make one comment about this. You know, we said that one form of an equation is y equals mx plus b. And you guys may not remember this. It's in my mind right now because I just talked about it with the pre-calculus class. But when we did our linear regressions on the calculator, one of the options was this. They kind of switch these two terms around. This is what they do in Europe. This is their form of a linear equation. It makes sense here because, you know, your y-intercept is your starting point, and then you're adding a certain amount, that's your slope, depending on how many years you have here. So again, I think Europe, the way they think of their linear equation, it helps make this a little bit easier to write and to think your way through. All right, so let's see, our next problem, sketch a graph of this line. So we're giving an equation that's in general form. What we want to do is probably put it in slope-intercept form because I think that's the easiest way to graph, and then go ahead and draw a quick sketch. So you guys go ahead and try it. All right, so what I'm going to do first is I'm going to solve for y. So I've got 3y equals a negative 2x plus 6. Okay, move these two terms to the other side. They just become the opposite. Divide everything by 3, and I get y equals 2/3 x. Divide that by 3, I get 2. And now I just need to draw a sketch of what, where Where's my stuff? There we go. Now I just need to draw a sketch of what that graph looks like. So I've got a y-intercept of 2, a slope of 2/3, which means I'm going to go up 2 and over 3. Do that again, up 2 and over 3. I could also say that a -2 over a -3 is the same thing. So I could go down 2 and back 3, and now I could draw my line through those points. There it is. All right, so for this problem, they're asking us to find the equation of a line perpendicular, remember that's the symbol for perpendicular, to this equation, 2x plus 4y minus 5 equals 0, and through the point 1, 3. So anytime I see those words, find the equation of a line, I know I need a slope and a point. I've already got a point. I just need to figure out what that perpendicular slope is. You guys go ahead and try it. All right, so I've got my point right here. I just need the slope. So I'm going to take this equation, I'm going to go ahead and solve for y. So I've got 4y equals a -2x plus 5. I'll divide everything by 4 to get y by itself. And at this point, I don't really think I need to write anything else down here. I see the slope right there. Y equals mx plus b. So my slope is going to equal a -1/2. So my perpendicular slope, negative reciprocal, so flip it over and change it to the opposite, and that'll be a +2. And so now I can write the equation of my line. Y minus the y value equals the slope times x minus the x value. You know, if you're taking the AP test, one of the things that they say is you do not have to simplify, which is kind of nice. I could stop right here, right? Now, most people probably won't take the AP test, but there's always a few who say, yeah, I just want to take it. You know, maybe you get those extra elective credits at the college that you attend. I know that happened with my son up at Western Washington. He got credit for the AP test, but then somehow he got talked into taking calculus again, which he later found out was a mistake. But because he took calculus at the school, he got credit for that, and they gave him elective credit for his AP score. So I could stop right there if I was doing the AP test. In our class, we always want to simplify things as far as we can, so we want to get this down to the point where it's in slope-intercept form. So I'll distribute the 2, and then I'll add 3 to the other side, so I get y equals 2x plus 1. There's the equation of the perpendicular line that goes through that point. It's perpendicular to this, and it goes through that point. Now, if I wanted to check this on my graphing calculator, I could go ahead and graph this. Y equals -1/2x plus 5/4, and graph the perpendicular line. And I should see that they're perpendicular to each other, and I should also see that this goes through that point. Now, I got to be careful there when I say we should see that it's perpendicular. It depends on what window you're using. Because you could change your window on the graphing calculator and have it distort the picture so these two lines don't look perpendicular. That's why I always do the zoom option 4, is because it'll show a graph the way it should really look. All right, one more problem for you guys. Let's see if we can find the equation of a line through these 2 points. And remember last year in pre-calc we push things a little farther. Sometimes numbers get a little messy. We should look at this now, and it's okay to go, oh, fractions. All right. But we shouldn't be scared of it, Numbers are a little messier, that's okay. We still do the exact same procedure, right? So you guys go ahead and find the equation of this line. All right, so again, first thing I need to find is the slope. So slope equals, doesn't matter which one's 0.1 or 0.2, I'll just go y2 minus y1. So 3/4 minus a -1/4. And then I've got 7/8 minus 5/4. So I can go ahead and just add or subtract the fractions if I want. We had this one thing we did last year where whenever you have fractions within the fraction, you multiply everything by the least common denominator. So I can multiply all these by 8 if I wanted to. This particular time, I'm seeing right away that when I add these, I get 1. Here, if I get a common denominator, it's fairly easy. I'll multiply top and bottom here by 2, so I get 10/8. So 7/8 minus 10/8, that would be a negative, whoops, what happened to my 1? Alright, so add these, you get 1. Here, this fraction would be 10/8, so 7 minus 10, that would be a negative 3/8. And 1 divided by a fraction just means flip it over. So my slope is going to be a negative 8/3. And now I just need to choose one of these points to work with. So I'll just go with that one right there. Y minus 3/4 equals our slope, which is a negative 8/3 times x minus 7/8. And so if I distribute that, I get y minus 3/4 equals a negative 8/3. Remember, be careful with that x. Make it big. I don't want it to look like it's in the denominator. Negative times a negative, that's positive. And I'm going to get 56/24. And so now I just need to move this negative 3/4 to the other side and do the opposite. So I'm going to say let's add, and I'm going to go ahead and get a common denominator right now. Multiply 4 by 6, so I'm going to multiply the top by 6, that's 18/24. Right? So when I move this to the other side and do the opposite, that fraction is equivalent to this one right here. And so now I've got y equals a negative 8/3 x, and I've got 74/24. So that can be reduced, right? I want to make sure and do that. If I was taking the AP test, they don't care. They'd go, all right, that's good. But let's see, if I divide by 2, I'm going to get 37/12. And I think that's as far as it goes. So if the directions would have said, give your answer in general form, then what I would do is I would move this fraction over here to make it positive, this one as well, and then to get rid of the fractions, I just multiply everything by 12. Then I would have it set up so that my coefficient in front of x is positive, and there's no fractions in the problem. All right, there it is. That's what we have for today. Just working with linear equations. Okay, remember, we're just reviewing things from pre-calc from last year that are important to us to kind of get through and get started with calculus this year. All right, let me get you guys an assignment. All right, so here's our second assignment. You guys would have already turned in your first assignment through Teams. If you haven't yet, do that, but don't include this with it. This will be our second assignment, okay? We got page 16, 17. This is in the new book now, not the old book. 5 to 23 odd, 27, 43, and 47. Also, registration forms for Central Washington. You want to work on that? Hop on to the Sway page. Go ahead and get that filled out. As long as you took got Central Washington credit last year, and they changed a little bit. I believe they said you could get a C- or better because of the COVID thing. Then you have met the conditions or the prerequisite to register for this year. So if you did that, you're set. You don't have to do anything else. Just do the registration form, email it to me. I'll get all that stuff into a pile and get it sent off. Okay? All right, that's it. You guys have a good day. I will see you on, Wednesday is book checkout day, so I'll see you if you come in and get a calculator. But we have nothing going on Wednesday, since I'll be outside all day checking stuff out. no additional lesson. Okay, so I'll see you guys on Thursday. All right, take care.